Good afternoon. This is Sifat Karim Chowdhury. Today I'll talk about the underlying physics of complex physiological phenomena from mechanical engineering perspective. Did you ever dream to go to space? I think most of us, right? But space traveling always carried out great physiological risk from the very beginning because of the exposure of microgravity. As the hydrostatic pressure gradient changes over there, the blood volume, which is supposed to be pulled in the leg, now moves toward the upper part of our body. In a recent study, NASA showed that at least 4 out of 11 healthy space crew got altered blood flow on their neck veins, like a stagnant flow or reverse flow. In fact, long-time sitting during the regular flight could do the same kind of complexities in the leg veins. Even some of our daily bad habits, like smoking, could do the same to us. Pulmonary vessel occlusion is just a reference. So these are a few kind of background examples where we could find collapsible blood vessels and where fluid structure interaction is very, very crucial. So we started our experiment with the Starling resistor, which is pretty fundamental mechanism to observe collapsible vessel wall reaction under changing transmural pressure. Transmural pressure is defined as the internal pressure relative to the outside pressure of that vessel. During the next phase of our experiment, we ran pressure-driven flow for a range of Reynolds number. Reynolds number defines the flow speed, and we found that right after the exposure of a negative transmural pressure, the tube started to deform. It deforms from perfect circle to ellipse to the start of buckling, and finally it gets collapsed by touching the opposite walls. You will be surprised to know that a specific range of that negative transmural pressure triggered self-excited oscillation, which is induced by the total tube wall deformation and the pressure acting on that wall of the vessel. As the blood vessel, as the blood flow rate is not uniform in that condition, those kind of instability may hinder in-time collection of oxygen-poor blood from vein to lungs, or restrict the nutrient and oxygen supply to the tissues downstream of the arteries. In summary, my research showed that under altered conditions like posture or gravity or occlusion, the altered unsteady hemodynamics might be potential reason for those complexities we already observed earlier. So more studies in future will help us to know the problem better, as well as design effective countermeasure for the patients. That's all for today. Thank you.